This is part 6 of the bicycle fork video. At the end of part 5, we made it all the way to step 14, which gave us one blade made as a boundary and a trim at the bottom in order to allow us to add the fork dropout plate. In this video, I plan on finishing the entire fork by going through steps 15 through 27, which I'll just briefly walk through now. Step 15 will be to add the actual dropout plate. We'll add it slightly oversized. We'll add the dropout slot itself. And then we're going to clean up the leading and trailing edge so that it matches the curvature of the blade. This will be done with a swept cut along the leading edge and a swept cut along the trailing edge. These do not perfectly blend together yet, as we can see from the zebra stripes. So what we will do is cut out a little portion in between and then repatch this with a boundary that goes tangent to the surfaces above and below, giving us a nice blend. We'll finish up the dropout with fillets along the edges and fillets along the dropout slot. That completes a blade with all the details for the dropout plate and slot, and we can finally mirror this entire assembly to the other side. Then it's time to add the crown. In this video, I'm going to cut the top of the blades off and then build a new boundary for the crown itself. Add the steering tube as a thin-walled extrusion, and then finish everything up with a fillet on the upper edge of the crown. So let's roll back to step 14 and then start constructing step 15. What we are going to do is add our dropout plate, and we're going to add it a little bigger than it actually will be in the final design. I'm going to create a new sketch on my fork dropout plane, which is included in the inserted master file. So here's my fork dropout plane sketch, and I will make my front layout sketch visible. What I want to do is copy these lines that represent the dropout plate using convert entities. And this one here. And we'll trim away the excess and this portion here. Now what I want to do is offset this edge a little bit to make the oversized dropout plate. So offsetting about 1 millimeter. I'll delete this line and I'll change all my original lines to construction, and I will extend this line out, trim this away, and actually this line should not have been construction, so I'll change that back to a solid line. So this will be the perimeter of my extrusion that will make the dropout plate. I will also make my tilted sketch on the right tilted plane visible, so that I can see the thickness of my dropout plate. I can now do extrusion up to vertex. I can choose this vertex here, and that will give me a dropout plate that's exactly the width of the trimmed down portion of the blade. I'm going to leave this unmerged. The next step will be to add the dropout slot. In my sketches on the inserted master file, I have the fork dropout layout. I will make that visible. And once again, on my fork dropout plane, I'll make a new sketch. All I have to do is copy these lines that represent the slot and cut that out of the plate using convert entities. Extruded cut, flip the direction, and make sure it's cutting through the correct body which will be this one here. And that completes the slot. The next step is going to be to cut away this excess material along the edge of the dropout plate so that its contour, where it meets the blade, matches. I want to do that on the leading edge and on the trailing edge. This contour is probably not quite the same on the leading edge as it is on the trailing edge, so what I want to do is two separate swept cuts, each one starting at the top of the plate and finishing right in the open slot. I don't want to do one single swept cut wrapping around the bottom and coming up to the top because it's almost guaranteed that it won't properly match the trailing edge of the blade. The first step in this process is going to be to make the sweep path. So sketching once again the fork dropout plane, I'm going to copy these lines and this line to create a sweep path. So using convert entities, I'll copy this, this, and this. And I will add a construction line going from the center downward. And I will trim accordingly. So I'll get rid of this excess here, and this portion here. And this portion I'll just make a construction line. So now I have a sweep path that starts at the top of the plate, wraps down around, and finishes right in the middle of the slot. Closing that sketch. It's time to draw the profile that will be swept, and I'll draw that on the top of the plate. What I want to do is copy this curved edge. And I will also copy this edge of the plate and this edge. Trim the excess. Looks like I didn't get this one here. Trim the excess. And I'll drag this out just a little bit and finish this enclosed area. Make these perpendicular. We see what's happening here is this is the widest point of the blade, and by adding a little extra to the dropout plate, I'm guaranteeing that this profile, which is going to be swept around this area, will always be cutting into material. If I didn't oversize this plate, it's possible that this widest point, when trying to cut the widest point of the plate, would sometimes not give us a clean cut, and we would get a less than desirable result. Here we are guaranteeing that we are always cutting into material by making this a little bit oversized. So I'm going to add a dimension to this side here. Make that about 5 millimeters. The dimension isn't too important as long as it's not too large. If it's too large and you have a sweep path that curves inward before curving outward, the profile can end up crossing over itself and causing an error. So keep this down between 3 and 5 millimeters. So we'll finish that profile. We have our two sketches that we can make a swept cut. Going to Features, Swept Cut, choose our profile, our path. We want to make sure that this is the body that is cut. You can see in the highlight that this is ending right in the middle of the slot, so it won't be cutting any of the trailing edge. And there's our finished cut. We can see that this matches up right at this edge. That completes step 17. For step 18, we will repeat the process for the trailing edge. So once again, making a new sketch on the fork dropout plane. I'm going to copy this line, and this line using convert entities, and drawing a vertical center line from the center of the axle. That allows me to trim back this excess so that this path ends here, and trim away this excess here. Convert this to a construction line, and this gives us our path. To make the profile, we will sketch on the top of the plate, Copy this edge using Convert Entities, and also copy these two edges. Trim away the excess so these lines end at these corners. Drag this out a little bit. Finish the enclosed area and make these perpendicular and add about a 5 millimeter dimension to this line. Finish the sketch. Now we can do the swept cut once again. Choosing this as our profile, this is our path. You see once again it's going to end around the middle of the slot, and we will choose the plate in our feature scope. And we've just completed step 18. So here we can see how this contour blends into the leading edge of the blade. This contour blends into the trailing edge. If we turn on our zebra stripes, we see that even though these match up, they aren't tangent to each other, so this isn't a nice smooth blend. The reason for that is that the plate is going straight up and down, but the blade immediately changes directions and is angling inward. What we're going to do is cheat a little bit, take out a little piece of the plate, and then blend it back together using a boundary. Making my sketches visible again, and once again drawing on the dropout plane. I will draw a line that is parallel to this line sketched in the layout sketch. And I will make that about 3 millimeters. We're going to cut the top 3 millimeters off of the dropout plate. Extruded cut. Make sure it's going this way. Select the plate. And that creates a gap between the plate and the end of the blade. Step 20 is to build a bridge now that spans this gap using our boundary. And we'll click on this face. I'll do it near this corner. And I will click on this face and try to click near this same analogous corner so that these link up properly when I make the boundary. What I want to do is set both faces to tangency to face. What that will do is make all of these outside surfaces of the boundary tangent to all the surrounding surfaces that it connects to. So now if I turn on zebra stripes one more time, I see that that little patch has then created a nice blend between this portion and this portion. We see the zebra stripes connect together. We also see that this patch is still perfectly flat in this zone, and this flat area is going tangent to this trimmed down area. It's important that you've drawn your tilted right layout sketch so that this trimmed down area was going tangent to the straight line that represents the dropout plate. If it's not, when you try to put this patch in, you won't be able to get this boundary to go tangent to this portion. The next step is to put some fillets on these sharp edges. I'm going to put some 1 millimeter fillets going around this perimeter on both sides. And if I'm lucky, I can just click on one edge, and the fillet will follow all along the tangent edges. If you can't get it to completely go around the perimeter, try clicking on more than one edge to force it to wrap its way around. So this is the front side, this is the back side. We got lucky this time. Now what I want to do is add a small fillet that's going to run around the perimeter of the slot. Because we added these fillets along the edges, this has become one contiguous perimeter that will run from the outside of the plate all the way to the inside. I'm just going to put in a 1/2 millimeter fillet, and I should just be able to click on one edge. We see that that wraps its way all around automatically. Again, if you can't get it to wrap automatically, try to click on some additional edges. So we just completed the entire blade and the attached dropout plate with slot. The next obvious step is to mirror all of the work that we've done. So choosing mirror and our front plane, we're going to use the bodies option and mirror the entire blade with the dropout. Now we have something that's starting to look like a fork. So now we're just 4 steps away from completing this. We still have to add the crown and the steering tube. To add the crown, I'm going to cut away a portion of the top of the blades and then blend a nice crown into this cut-off section. The cut-off area will look something like this, and I'll show you how I made that. Turning my sketches back on and sketching on my tilted right plane, I'm going to just do something simple like draw an arc, and I did this mainly through experimentation. And I'll draw a center line coming down coincident to the arc, and I'll make this center line coincident with the steering axis, collinear actually, and I will make the center of the arc coincident with this construction line that I made, so that the arc is symmetrical on both sides of my mirror plane. Now it's a matter of just deciding how far down do I want this cut to be and what sort of a radius. I ended up making the cut come about 9 millimeters from the top of the blade, which is also the same as the top of the diamond in this view. And I gave the arc a 100 millimeter radius. Again, I did this through experimentation, just deciding what looked good to me, and you might have a completely different shape and different dimensions. Then I simply extruded that cut, flipped to the other side, leaving this zone here that I can blend the crown into. The top of the crown is here. Remember that we put a plane going through there, the crown top plane, so I will sketch on here. I also had drawn a little circle here representing the top of the crown, so I'll make that visible. I might as well just convert entities on this circle. So convert entities. That gives me the top profile for the crown. Let me hide the circle that was in the crown layout sketch. Now it's time to make a boundary, going from the circle that we just copied down to this surface. So I'm going to click near the center here, and click this surface near the same center. Now it's going to bridge from a sketch to a surface. We see that right now these are not blended together very nicely. So where it says face here, in direction 1, I'm going to change that to tangency to face. We see now that the boundary is curving and then meeting the surrounding surfaces of the blade to blend smoothly. But up here, this is where the head tube of the frame is going to be. We want the crown to also curve and then blend nicely into that head tube. Since the head tube is probably going to be a simple extruded circle, what we want to do is make sure that the boundary is going in the same direction of the extrusion right where it meets it. So we're going to go to the sketch here in direction 1 and change that from none to normal to profile, so that when this is assembled with the frame, and here's where our head tube is going to be, the direction of the boundary and the direction of the head tube will be the same to create a nice blend, even though they are actually separate parts. Finishing that, And if we just check this out with our zebra stripes, you see how the crown is smoothly blending in to the blades. Our second to last step is going to be to add the steering tube. Turning on our sketches one more time. You have a choice on how we do this. We could just copy the center axis and this line into a new sketch and revolve around the axis, or we can draw a sketch on the top face of the crown and extrude a tube up to either of these vertexes. I'm going to draw a sketch on the top here. Draw a circle, and it will pierce the center of the circle to this line here and make a coincident relation between the circle and this point here. Now I can extrude this circle up to either of these vertices. I want to make this a thin wall extrusion, so activate thin feature, make that 3. You'll notice right now that it's adding the thickness to the outside of the circle. I want to make sure I add it to the inside, so I'll toggle the direction. If we go the wrong way, we're going to have a tube that's too large. So there's my steering tube, complete that. And my last step is to go back to the crown and just put a little bit of a radius along this edge. A ½ millimeter should do it. And that completes all the steps for our bicycle fork. I will just mention that we don't have to build a crown exactly the way I did. It depends on the style that you want. This is a very blended sort of design. You can always do a crown that's nothing more than a simple revolved cylinder that's blending into the blades with a nice big fillet at the intersection. Or you can try something like this where, once again, the crown is a boundary, but it's intentionally not blending into the blades. But it is going in this direction to match perfectly with the head tube of the frame. In this case, I made the boundary similar to the way I made it before, starting out with a sketch up here and a boundary going down to the surface. But I also added some guide curves that control the shape of the boundary as it goes down to the blade. Then I added a nice fillet here to blend this shape into the blade itself. Of course, you're not limited to just these 3 options. There's other shapes I'm sure that you can come up with. So that completes this video series for the bicycle fork.